This is Jim Purjong. I will explain introduction to network simulation such as OMNet++ and Sumo. The recommended installation environment for simulation for OMNet++ and Sumo, if you use Windows system or Mac OS as a host operating system, I recommend to you to use VMware Workstation Player as the hypervisor. So host your guest OS Ubuntu Linux because our in the in the Sumo for simulation for 5Z, the Linux based one is more stable. It's good. So according to this table, you can install Ubuntu Linux on the and the Sumo. The package is on the for simulation for 5Z, Sim 5Z. Also, you can install the Veins for virtual network simulation. And INET framework is needed for TCP/IP networking. First of all, you can install VMware Workstation version 17. You can visit this URL. You can see this screen. You can push this download button, and you can get installation binary file. So go to this. Click this one, and then you can here download Linux or the Windows version. So if you're using Windows system, you can click this one. Okay, and then Ubuntu. So Ubuntu is Linux, right? So you can go to this Ubuntu. So ubuntu.com. So you can download Ubuntu, right? So you can download here, and then after that, so once you install the VM player, you can create the new virtual machine for Ubuntu, right? Create a new virtual machine, and then select the image, ISO image for Ubuntu, right? And then you can proceed next, and then you can install Ubuntu over VMware Workstation. After that, and you can install OMNet++ for network simulation. So OMNet++ is a public source, open source code, component-based, modular, and open architecture simulation environment with a strong graphic user interface (GUI). OMNet++ provides a component architecture for models. Components called the modules are programmed in mainly C++, then assembled into larger components. It is called a composite component, and the models using a high-level language NED. Okay, so OMNI++ is free for academic and non-profit use. However, the commercial users must obtain a license from OMNest Global Incorporation. So OMNI++ you can get here, OMNest you can get here. So the comparison between OMNI++ and OMNest, you can click this one. Okay, link. So platforms, OMNet runs well on Linux, most other Linux-like systems, also Windows system, Windows 10 and Windows 11. So third-party software is required, like C++ compiler, TCP/PK, Perl, and graph.pig, GoScript. Applications for simulations. OMNet++ is an object-oriented modular discrete event network simulation framework. It can be used for various simulations. For example, modeling of wired and wireless communication network, and tracking modeling of telecommunication networks and queuing networks, multi-process distributed hardware system, and evaluating performance aspects of complex software systems. OMNet++ frameworks simulation frameworks based on the plus plus. There are many projects. INET framework, Castelia, Maxim base. So INET provide TCP/IP protocol stack for wired and wireless simulation, and then Bain's virtual network simulation providing IEEE, IEEE 11 OCD. OCD stands for outside the context of a basic service set for adult networking. So this code shows basic operation of OMNet plus first event-driven operation. Initialize. So we make a message pool simulation case. Message event is important. Okay, so make the event based on the C message. Okay, and the schedule. Okay, at time. So sim time is the current simulation time plus one. So current simulation time plus one unit time, you can define a second, millisecond, depending on your purpose. Okay, so event here, and then after this simulation time, okay, simulation time plus this. Okay, so this simulation time and the event handler code. Okay, so event, okay, handler message code, and then parameter the event you made previously initialized, and then the event name is pool here. The message event name is pool, right, is equal to pool. You do something, and then after that you can schedule again a simulation time plus unit time, and the event will be handled. Okay, so this is the basic the discrete event simulator. So in order to simulate on the plus plus, you need to install the version 601. So you visit, click on the org, okay, or in the plus.com, or in the pp.org, and then you can go here, and then you can right hand side download. You can click download, and then so you can click this download, okay, and then you can install in your Ubuntu Linux, okay, and then so you can also install INET, other example tutorial, okay. So if you install this tutorial, one typical example is TikTok. TikTok is an example of OMNet plus simulation, okay. So you have a network description file, NED, and this actual the OMNet TikTok or C++ code .cc. Okay, so we make a simple component, and then with the two simple component tick and top. Okay, here tick and top, and then we make connect. Okay, and then make the network composite component. And here right hand side we have the public. So the tick and top, right? The class is here from inherited from the C simple module. Okay, so initialize and handle message are virtual function we needed to implement here. So initialize and the handle I will explain one by one. So the NAD file is used to make simple component and the composite component with multiple component, simple component. So simple component is TM talk. So it has two ports. It is called the gate. Input gate and output gate. You can define like this. Okay. So define input gate and output gate. And the TM talk network composite module consists of two sub modules. Okay, tick and talk. So tick and talk is okay based on this class. Okay, so txc1. So we define this object, tick object and the talk object. Okay, so tick and talk even exchange the okay the token okay as a like a ball okay catch okay. So connection. So tick out is connected to the top input gateway, and the delay is 100 milliseconds. And then similarly, talk output gateway connected to TIC input gateway. The length is same, 100 millisecond. Okay, we link. Okay, two gates. Okay, so after that, we define. Okay, so virtual functions initialize and handle message here, right? So here initialize. So here we make the object here. So okay, here, right? So tick and talk, right? Tick and talk is the module name, right? Tick and talk. Okay. So and then tick and compare the okay simple module name is the can name is the module name is the same case. Okay. So you message TikTok message generate, and then this message is transmitted this tick object the output gateway. So this output rate sent. Okay. Eventually, the 100 millisecond ticks. Okay, output sending right, and then talks the input gateway receive this message, which means 100 millisecond. Okay, talks. Okay, input receive. Okay, and then receive, and then it send out its own output. So um, talk output gateway sends this message toward the text input, and then text handle message received. Okay, so you execute TikTok the example, and then we have talk and tick. So they okay, give and back. Okay, so post and then receive. Okay, alternatively. So there's the same message. So you can see this example. INET. So INET is an open source model library for the plasma simulation environment, especially TCP/IP protocols that are provided, and also agent other model for researcher working for TCP/IP based computer networks. And the INET installation. So you're going to INET. So OMNet plus website providing the link for INET. So you can go to INET, and then you can, okay, depending on your OMNet version, you can select the stable version of INET, and then you can install INET. Okay. So during OMNet plus also you can install INET framework. Okay. And then so build the project INET. So once you uh, download and then build the project. So you import this one, and then you can run a simulation and then make INET, okay, binaries. And then Sim5 is for simulation for 5G network. Okay, so Sim5 is the evolution of popular SIM-LTE 4G network simulator that incorporate the 5G new radio NR access. Okay, you can click this one. So based on the plus framework, it is written in C++ and is fully customizable with a simple browser interface. Okay. So this figure shows the OMNet SIM5G. Okay. So you can see we have a station called the Chinode B. Yeah, right. So user equipment is smartphone or beacon. So user equipment connected the station Chinode B. Also, we have multiple functions like UPF, user plane function, and this is internet data network. So also we have edge computing, mobile edge computing, multi access, okay, edge computing servers here, okay. So the handover or interference combination can be done, okay. So Simu 5G installation, you click the Simu 5G ORG, and then you can download zip over G, and then import, okay, and then use the project in the workspace, select, and then build the project. Okay, so you select, you always select the simultaneously and the build. Okay, after that you can properties, and then you going to here project references, and then INF. Okay, click. Okay, or single privacy case or single privacy. Okay, so the project references for single privacy INF. Okay, you can link like this. Okay, after launch of single privacy, so OMNet plot was ID integrated development environment. So you can go to single privacy port and the simulations, and the NR is your new radio 5G, right? And the networks, and then multi-cell stand over this one, and then launch. So you can see these kinds of example that we can launch. Okay, so multi stand alone NED file. So NED file is client compilation, right? Network. Okay, this one is a conversion. Okay, of component. Okay, module and the sub modules, the simple modules. And then in order to run simple5G OMNet, the OMNet pp.ini initialize file, okay, and then you can run like button, mouse button, and then you can click to run simulation, okay. So here, compilation multi-cell network and the simulation limit and the description you can. And then Sumo. Sumo is a different simulator. So when the plus is for wild, and then one is a simulation. And the Sumo is network mobility simulator for simulation for urban mobility. Totally different simulator. Sumo is an open source simulator for the simulation for urban mobility. You can click, you can get the Sumo installation file. It is designed to support the simulation of road traffic signals and the mobility of vehicles and pedestrians. Sumo supports the realistic mobility of vehicles with the car following model. So car following model is car is moving, and then the distance maintained to avoid accident. Okay, so realistic the mechanic model for vehicles. So you can install a Sumo installation according to this one. So you can install the latest version, but currently our installation is a little older version. So installation of the car tools for Sumo, Ubuntu, you can apt-get update the library information, and then you apt-get install. You can install like this kind of libraries, okay, and then Python 3, and you can build okay libraries, okay, and then installation of Sumo. After that, you can go to this link, and you can download Sumo, and then download the source code, and then unzip, and then you can go to the Sumo 1.12.0 version case, configure the path. This is binary path for Sumo, okay, and the make, okay, and then the make is done. The binary directory can go, and the Sumo can active. So the Sumo, and then you can see Sumo the ID environment. The basic Sumo tools. So using net generate, okay. So road network generation you can do using net generate, okay. So net generate explains, okay, this case you can make it, the number of the lanes, and then and road size you can define, okay, using net generate, using. And then the open straight map is provide realistic map like some Seoul or Suwon 성균관 University. You can using this open source open straight map, and then this map is integrated into a Sumo. Sumo can learn realistic local map, okay, using. So you build it, and then I can report to them. And then net convert. So this tool is used to conversion. Okay. So row data import and conversion is used. Okay. So the net convert command you can report to this one, and then you can use it. And then the beaker in the load method. Okay. So once you generated random traffic in rotor, and then so we learn this kind of random traffic trees. Okay, over um, this is a load traffic. Okay, in the sumo, so you can see the example running over sumo. And the import base project. Um, how does the base works? The OMNet plus sumo. So OMNet plus is a network simulator, right? And then sumo is a load network simulator. So we combine the two kind of simulator, and you can see the base. Okay, the base is OMNet library. So this provide the traffic efficiency, traffic safety, comfort. This kind of a model is provided. Also, it contain Alpha 11 OCD mode. Okay, like um, so base is IEEE Alpha 11 OCD. So OCD means outside the context of basic service set. This is a kind of, in the past, you know, 11P. Okay, so the 11P is this for DSRC for nuclear communication, dedicated short range communication. So the base is a bridge between the OMNet plus simulator and the Sumo. Okay, and then they can integrate. Okay. So the base learning view. So OMNet shows this kind of view and a sumo view and OMNet view. So actually two simulation learning are together. Okay. So some beaker is moving a little bit and then generate a traffic. And then OMNet plus first consider physical and the MAC, TCP/IP protocol stack, consider radio, some fading. So the sumo case, the moving beaker a little bit, and the actual packet generated by ONNet. So interaction between two simulator performing some privacy vehicular methods. Okay. So installation of the Bain, so you can visit the Bain's website and then download. Okay. So and then according to this sequence, you can install. So download Bain's version, latest version, okay, and then open a terminal, and then so type on the pp to start on the plus ID. Okay, you can start. Okay, and then import the base. Okay, so you can go to menu file import existing project into workspace. Next, browser choose the folder base and then finish. Okay, you can existing and then finish. Okay, next. And then select the root directory of your base project and click OK. In the import project, you can go to base and then you can click this project. This is the same way import INET or other plus packages like the Simo privacy to the workspace. Running Sumo. So and then once you okay, install the base and then to connect to Sumo when you run base in OMNet++, Sumo launches Python -3 -d Sumo GUI, and then you can run, okay, Sumo connected with OMNet++. So launch base, base, okay. So in project is prologue and or in the plus ID integrated developing environment, right? So right click mouse base project, and then choose a build project, and then you can choose, okay, this one, and then it takes time. In project portal, you find, and then you can execute some example file. Like once you build the base, we have this kind of the menu in the plus plus ID is possibly a project explorer, and then a base in the example result, and then you can click this one, right mouse, okay, button, and then you can click simulation. Okay, so this is a typical virtual network simulation. This is implemented by my lab. So multi-hop deeply address detection in virtual network. Okay, so you can visit this YouTube link. You can see the multi-features initialize their IP.6 address, and then moving and then sending the message through the sign unit and mobility anchor. Okay, and then this project case, virtual network project, the components are beakers, auto sign unit, and the scenario. Okay, so those are okay constructed. Okay, this one is scenario NED file. This is RSU and the car NED. So car is the beaker. Okay, so the beaker is used to simulate the car. Auto sign unit is deployed in load network as infrastructure nodes. And the scenario is in modules. We mainly have application, MAC protocol, video access protocol, video access control protocol, and the message is NAC network interface card, obstacle, mobility, and the physical layer subdirectories. So you can have this kind of directory. Okay. And then, so this figure shows the ONNet module, okay, for car and then network interface. So NEC L11P, this is the DSRC dedicated short range communication. So this is the PI and this MAC, okay. So this is actually 1609.4, okay. This is the MAC protocol for DSRC, wave protocol. Wave stands for wireless access in virtual environments. Okay. So in summary, the ONNet++ is a computer network simulator for packet delivery in wired and wireless networks. Secondly, Sumo is a load network simulator, okay, for mobility of vehicles and pedestrians in load networks. Thirdly, base is ONNet++ package or library for L2.11 OCD or L2.11P based virtual networks by combining ONNet++ and Sumo. INET, this is the ONNet++ package for TCP/IP networking. And lastly, the SIM 5G is ONNet++ package for 5G new radio simulation. Okay. So this is the references for those simulations on the Sumo, base, INET, and SIM 5G. If you have a question, please let me know. Thank you for your attention.